Alright, in this video we look again at section 15.5, but we try a different style problem. So in this problem you'll notice that the region has been given to us. Okay, and we have some formulas that are describing that region. Okay, so we have a given region and we want to turn this sketch into a triple integral. Okay, that gives the volume of the region D. Okay? And they want us to fill in essentially all the blanks. And all the blanks look like this. We need to decide what function we're going to integrate. We need to decide what is our order of integration going to be. And then we need to fill in all of the 6 limits of integration. Okay. Part of this is straightforward. We know that since we're finding a volume, we know that we're integrating the function 1. Okay. And then we need to decide what our order of integration is going to be. All right. So typically, like starting with dz is usually the obvious first place to start because we're trying to go from the bottom surface up to the top surface. So we want to choose any value of x that is in this little circular region here. So if you pick any value of x and y in that circular region, we want to read that up to the surface. Okay, what surface is on the bottom and what surface is on the top? So here's bottom and here's the top. And I think we can see that z equals 0 is on the bottom because that circle is sitting in the z equals 0 plane. So we don't need to think any more about it at this point than that. We're in the z equals 0 plane. And then we're integrating up to the plane, which is z is equal to 3 minus x. And once you've made that decision, we can then move on to perhaps the dy integral. And now we are having to decide how to restrict the x and y values. Not only do these dots that we pick have to be in the z equals 0 plane, but we need to make sure that they stay inside of this circle. And that circle we can see is given by the cylinder. Because when z is equal to 0, we have a circle in the z equals 0 plane of x squared plus y squared is equal to 4. So it's a circle of radius 2. And because the picture is showing us the whole region, the whole circle there, and we want to find the volume over every point, then we need y to go from the bottom part of this circle, which is negative square root of 4 minus x squared, up to positive square root of 4 minus x squared. So there are the y limits of integration. They're just a description of the circle. And we can see that by completing the, let's see what color, purple. Let's go to x. The x's, because x is going from here to here, which values of x, or because we're integrating over the whole circular region, x is going to go from negative 2 to positive 2. So that is a description of taking a region and coming up with the integral that represents that volume. And you'll know you have the right plot when you can check it, region plot 3D. You can say that just put in your limits of integration, z being bigger than 0, but z also less than 3 minus x. But y was bigger than the negative square root of 4 minus x squared. But y also had to be less than the square root of 4 minus x squared. And x had to be bigger than negative 2, but also x less than 2. And if we plot this, look at these inequalities plotted inside of a box, right? And let's say that that box goes from x going from -2 to 2, y from -2 to 2, sorry, little typo there, y from -2 to 2, and z going from 0 up to, it's not clear how high that should go. Let me see, when x is equal to 0, z is equal to 3. And when x got to be a +2, I'm thinking the biggest can be 5. That's my guess. Okay. So here is the region plot. I had a little error here. It's telling me kind of missing a comma. Let me see. Checking to see where I range -2 to 2. Oh, missing a comma again. So here is our region of integration. Plot points goes to 30. Again, we can see if we plot more points, the region of integration should look like what we had in the picture there. So it's kind of a flat plane. It's been chopped off. It looks like the tip of a lipstick, or it looks like, I don't know what that looks like. Whatever. Okay, so ends this video.